Day 161, Honors Physics, Photoelectric Effect, problem number 23. Our two basic equations are V equals lambda F, velocity of any wave, but in particular the velocity of the photons involved in the photoelectric effect, and E equals HF, the energy of a photon. I'm going to take a little different approach on this problem just to make it go a little faster. If I take and solve this equation on the left for F, F will be equal to V over lambda. Then if I plug this V over lambda in for F right there, I just get a combination of the two equations in the blue circle here. The energy of a photon is going to be Planck's constant times the velocity of the photon, which is a constant, divided by the wavelength. I will do this problem in electron volts because it'll be easier to compare to the table they're referring to. This table up here in the top, 25.1, let's just say that's the table in your book or some reference book. You have that in your notes. Table 25.1 is the work function table in your notes, page 161 or day 161. So bottom line is, if I figure out the energy of these low energy photons, or the high energy ones, I guess first, the ones with a wavelength of 380 nanometers, 380 times 10 to the negative ninth. So I'm, once again, doing this in electron volts, so I have the electron volt version of Planck's constant times the speed of light, 3 times 10 to the 8th meters per second. So you do the calculation there, that gives you the energy, the high energy photons. That'll give you the high number. And you'll repeat this last calculation, just changing the 380 to a 760. And basically 760 is twice as big as 380, so E sub 2 will come out half as small. So all you have to do, I guess, to take a shortcut is E2, the low energy photons, will be half the energy of the upper level photons. The upper level ones are, the indigo, the 380 nanometer is like indigo and violet, blue. And then the 760 is the red, low-end red photons. Anyway, you'll get a range from E sub 1 to E sub 2, high to low. And you just look in your table in the notes and see which metals are within that range. Any metals that are not in that range would not be candidates for the photoelectric effect or photoelectrons emitted, ejected photoelectrons from that surface. There'll be quite a few answers that'll be within that range. And those answers might not completely match up with what's printed in my answer sheet, because my answer sheet refers to a different table. It should have similar answers though. It should be a close approximation. You might have a couple, I think I added a couple extra metals in my table. So mine might have a few extra, or when you go through the calculation, you'll get probably a few extra metals that appear that are not on the answer sheet.